It's finally happening! SpaceX's Starship Flight 12 just achieved a crucial milestone. SpaceX just filed with the FCC to launch 1 million satellites with Starship. 100 times more than everything orbiting Earth today combined. And these aren't just for internet. They are solar-powered orbital data centers, designed to fuel the exploding hunger of AI. But a million satellite mega-constellation powered by Starship? How the heck do they even pull this off? And why now? My name is Felix. Welcome to What About It? Let's dive right in. Starship updates. It's finally happening! I always wanted to start an episode like this. SpaceX is officially beginning the Starship Flight 12 test campaign with the rollout of Booster 19. Jordan was out there to greet the brand new version 3 Super Heavy booster as it rolled out in the early morning on Sunday. I cannot overstate how important this is for SpaceX. As we all know by now, Booster 18 did not delay Starship Flight 12 as Pad 2 wasn't ready, and SpaceX performed the miracle of stacking Booster 19 in a record-breaking 4 weeks. Now it is ready to begin its test campaign. All the changes implemented from version 2 to 3 will now need to show their worth and hopefully pave the way for this highly anticipated first Starship launch in 2026. If everything goes according to plan, we can expect a launch sometime in March. It will have to prove a radically different booster design. It will have to demonstrate that Ship 39 and all following version 3 ships are ready for SpaceX's future and for NASA. It will have to demonstrate that the brand new and radically different pad design works. And last but certainly not least, it will have to prove Raptor 3. 39 of them will be installed in the Flight 12 full stack. None has ever reached space before. Booster 19 will now go through 2 test phases, one ambient pressure test and one cryogenic test. Once that is done, it'll roll back to the production site for engine installation, then it will roll to the launch site and Pad 2 to achieve the next very important milestone. A very first Raptor 3 powered static fire of a brand new booster design on a brand new pad design. So many things can go wrong, and so many things need to go right for SpaceX's plans, which have just gotten massively larger. Here's the big one for today. SpaceX has just filed an application with the FCC seeking authority to launch and operate a massive new satellite constellation dedicated to orbital data centers. How massive? As massive as it's never been thought possible. They filed for 1 million satellites. This is not a mistake. You heard me right. 1 million satellites. SpaceX aims to deploy a gigantic system of up to 1 million satellites to operate within narrow orbital shells spanning up to 50 kilometers each. The system is supposed to operate at altitudes between 500 and 2,000 kilometers in sun-synchronous polar orbits for baseline performance and in a 30-degree inclination orbit for peak performance spikes. SpaceX plans to design and operate different versions of satellite hardware to optimize operations across orbital shells. The system will rely nearly exclusively on high-bandwidth optical links for communications. These optical links will route traffic within the network and to satellites in the Starlink constellation via its petabyte-scale, high-capacity, high-reliability laser mesh, which in turn will transmit traffic to authorized ground-based Earth stations. So much for the official filing, but what does this even mean? Elon Musk has been very vocal about space-based AI satellites for some time now for obvious reasons.
One of the things we'll be doing with SpaceX within a few years is launching solar-powered AI satellites. Right. The space is really the source of immense power, and then you don't need to take up any room on Earth. So much room in space. I mean, you can scale to ultimately hundreds of terawatts a year.
The biggest problem with computational AI resources worldwide is power demand. It costs a lot of energy and in return a lot of money. AI processors consume a lot of power and require strong cooling, further raising power demands. In space though, these two problems don't even exist. Solar cells have a 5 times higher electricity output in space if placed in a sun-synchronous polar orbit. This means that the satellites are circling the Earth following the border between day and night in a sun-synchronous movement. This means that they shift by roughly 1 degree every day, staying in constant sunlight. This way they gather power by permanently facing the sun and dissipating heat on the side that's constantly in the shade behind the satellite. So once built and launched, it doesn't require upkeep. It just circles Earth, constantly gathering power from the sun and constantly calculating our needs for worldwide AI implementation. One argument often made about this idea is that heat dissipation would be very difficult in space. That's not really true though. While dissipation is slower in space due to the lack of air, it is absolutely possible. Imagine a long boom extending out the back of the satellite, always in the shade and easily large enough to do the job. It's never been done and it's impossible are two different things. SpaceX is an excellent example of this. The next seemingly impossible aspect about this is the number of proposed satellites. After all, there are around 14,500 active satellites in orbit right now. How can this turn into more than 1 million satellites? It's never been done and it's impossible are two different things. The main reason we have so few active satellites in space is that launch costs have been too high for the vast majority of active human spaceflight. Only in recent years have launch costs gone down dramatically thanks to SpaceX. As soon as that happened, the number of active satellites skyrocketed, pun intended. If costs go down to under $100 per pound of payload to space, launch costs won't be a problem anymore, and that is the goal of SpaceX's Starship. Building 1 million satellites is no problem at all. We build equally complex objects in even higher numbers. Take cars, for example. The total global motor vehicle production for 2025 is estimated at 90 to 94 million units. Far more than the proposed 1 million SpaceX AI satellites, so the only limiting factor right now is Starship, but how much are we talking? Our current knowledge says that a fully operational version 3 Starship will be able to carry 60 version 3 Starlink satellites. And a version 3 Starlink satellite is a beast. Current V2.5 Starlink satellites launched on a Falcon 9 weigh around 600 kilograms. Version 3 launched on a Starship will weigh around 2 tons. For ease of estimation, let's say that these proposed AI satellites will weigh the same. 2 tons should be enough for a pretty beefy groksat. Like the name? I made it up. SpaceX plans to roughly double the payload capacity from 100 tons on version 3 Starships to 200 on version 4. So we're talking 120 groksats per launch. 1 million divided by 120 equals roughly 8,334 launches. That sounds like a lot, but let's take a look. 8,334 launches are nothing compared to our audience. If you want to help us make even better content and fly more often in a helicopter, hit the subscribe button to stay informed. Like this video if it brought you value and become a wise supporter for those extra heli flights. Be our fuel, chat with me and gain more insights into the topic you love. Thank you very much, you rock. So is this 1 million satellite constellation achievable? Let's take the real world numbers first. SpaceX launched 165 Falcon 9 rockets in 2025. We can assume they will manage at least the same number with Starship if they manage to do so with Falcon 9. That would mean that SpaceX will need almost exactly 50 years to achieve this. That's a long time, but certainly not impossible. But do great things need to take 50 years? Sometimes results can happen in seconds. Alright, back to 1 million satellites, let's add some Elon factor to the numbers. He has repeatedly stated that SpaceX plans for far greater launch numbers with Starship thanks to its rapid reusability. Let's say they manage to launch from each pad once per day. For the record, Musk's estimates are much higher. He's openly speaking of launching the same Starship 3 times per day. But for the sake of believability, we're using a single launch per pad. SpaceX is actively planning or building 6 Starship pads in the US right now. 6 times 365 gives us 2,190 Starship launches per year. 8,334 launches divided by 2,190 equals 3.8 years. That's all. So while all this sounds like pure sci-fi, we have to keep in mind that all of SpaceX's plans have sounded like sci-fi since its inception. A private rocket reaching orbit? Never. An orbital rocket booster returning to a landing pad or a barge in the ocean and then being reused? Impossible. A 124-meter tall stainless steel Starship with 39 engines? Ludicrous. A super heavy booster being caught by a robot in the dunes of Boca Chica after having delivered a 120-ton upper stage to space? You get the idea. By the way, all of this has already happened. I'm somewhat of an expert when it comes to SpaceX and the broader rocket industry, and even while this might sound crazy right now, it can absolutely be done. To put this into perspective, those 1 million AI satellites would generate more power than the entire US economy does right now, without the need to rebuild the entire ground-based electricity grid. Even though they've achieved more than any other rocket manufacturer in human history, their Starship project is another one of those critical inflection points. If Starship works, it'll change space as we know it. And more than we know right now. NASA is working together with SpaceX and several other large partners to pave the way. The Artemis 2 mission has just suffered a minor delay. The planned date for the SLS wet dress rehearsal was shifted by 48 hours. Fortunately, it wasn't due to any technical issue, but simply bitter cold weather. For such conditions rarely experienced in Florida, NASA has strict rules in place. No test or launch attempt will be allowed in frigid conditions. The new date? Yesterday. So by the time you watch this episode, we've already passed this critical test. Take that, cold weather. And there's one more piece of NASA news I want to talk about. Administrator Jared Isaacman turned some heads when he explained plans for what he called a transcontinental railroad to Mars. He made clear that NASA has firm plans to land American astronauts on Martian soil in our lifetime, likely a lot earlier. Sure hope so. NASA's technological route toward this goal is through nuclear power and propulsion. In Isaacman's view, this is what will enable us not only to bring humans toward our red neighbor, but also to safely bring them back home, all without the need to produce fuel on Mars. To up the ante, the administrator promised that NASA would launch its first nuclear electric-powered rocket during President Trump's term. This spacecraft's mission is to cheaply deliver a lot of payload mass to Mars. The goal is nothing short of the first American outpost on another planet. Before we get there though, let's stay a bit closer to home. In March of 2025, a small aerospace company based in Texas did what several better-funded rivals couldn't. It landed a spacecraft on the moon. Not crashed, not tipped over, not mostly successful, it landed cleanly, upright, exactly where it was supposed to. The company was Firefly Aerospace. Unlike many competitors, Firefly wasn't just building rockets. It was also building a lunar lander called Blue Ghost, and this one was to become a true game changer. As part of NASA's Commercial Lunar Payload Services program, Firefly was paid about $93 million to deliver 10 scientific instruments to the moon. The goal was simple in theory: land on the moon, drop off the payloads, and survive one lunar day. In practice, commercial lunar landings had gone badly up until this point. Astrobotic's Peregrine never reached the moon due to a propellant leak. Intuitive Machines' Odysseus made it to the surface but tipped onto its side. The truth is, landing on the moon is brutally hard. There is no atmosphere, no parachutes, no gravity, no second chances. But on March 2nd, 2025, Firefly tried anyway. Blue Ghost touched down in Mare Crisium, a vast volcanic basin on the moon's near side. It landed upright, within 100 meters of its target. It deployed all 10 NASA instruments exactly as planned. For the first time ever, a commercial company had pulled off a fully successful soft landing on the moon. Over the next 2 weeks, Blue Ghost worked non-stop. It studied lunar dust, measured radiation levels, and tested GPS signals from Earth's orbit. By the time the sun set and the brutal lunar night began, the lander had transmitted 120 gigabytes of data back to Earth. After 346 hours of operation, Blue Ghost finally froze in the darkness. Mission accomplished. Success. $93 million. Interestingly, this wasn't just a win for Firefly. It was proof that NASA's gamble on commercial partners actually worked. Or could work. Instead of designing everything in-house, NASA paid companies to deliver results, and Firefly delivered. NASA leadership called Blue Ghost an existence-proof evidence that commercial lunar services could be reliable, affordable, and repeatable. And suddenly, the company that once went bankrupt was holding contracts for even more moon missions, including landings at the lunar South Pole, one of the most scientifically valuable locations on the moon. Today, Firefly has a contract backlog of around $1.3 billion. It works with NASA, the US Space Force, and major defense contractors. Blue Ghost has proven something far more important than any single rocket launch. That you don't need to be the biggest company or the richest to do something historic in space. Sometimes you just need to survive long enough and succeed when it actually counts. Because in the modern space race, Firefly Aerospace has shown that persistence still beats hype. And the moon just became a little more crowded. Crowded is an excellent segue, because low Earth orbit is about to get a lot more crowded soon. The Ariane 6-4, the heavyweight version of Europe's long-awaited Ariane 6, will lift off from French Guiana carrying 32 Amazon LEO satellites into orbit. On paper, this should be a moment of celebration. A brand new rocket, a major commercial customer, a clear signal that Europe is back in the launch business. But instead of excitement, this launch raises an uncomfortable question. Why is Europe's newest rocket only now flying its most capable version while SpaceX launches a Falcon 9 roughly every 3 days? This isn't just a comparison of rockets, it's a story about timing, strategy, and how quickly the rules of spaceflight have changed. Let's look at how Ariane 6 became a rocket built for a different moment. The Ariane 6 program was approved in 2014. At the time, SpaceX had just landed a rocket booster for the first time. Reusability was still experimental. Falcon launches were infrequent, and many in the industry believed SpaceX would remain a niche product. Or maybe fail altogether. Ariane 6 was Europe's answer to that specific moment. The goal was simple: build a reliable, cheaper replacement for Ariane 5 that could keep Europe competitive in the commercial launch market. The design prioritized stability, predictability, and industrial continuity across ESA member states. And technically, Ariane 6 does work. It comes in 2 versions, Ariane 6-2 for medium missions and Ariane 6-4. That is the one flying for Amazon LEO with 4 solid boosters for heavier payloads. At full power, Ariane 6-4 can lift over 20 tons into low Earth orbit and send large communication satellites toward geostationary orbit. That is the high-altitude parking lot where many of the world's most valuable satellites live. Ariane 6 is tall, powerful, hydrogen-fueled, and precise. Its upper stage engine can restart multiple times, enabling complex satellite deployments. And for this Amazon mission, it will debut a massive new payload fairing large enough to carry dozens of satellites at once. By traditional standards, Ariane 6 is a capable rocket. The problem is that spaceflight didn't stand still while Europe was building it. While Ariane 6 was in development, Falcon 9 didn't just mature, it evolved and multiplied. SpaceX didn't optimize for perfection, they optimized for iteration. A new tactic for a new spaceflight era. Today, Falcon 9 has flown more than 600 times. It launches so frequently that individual missions barely make headlines anymore. SpaceX now sends more mass to orbit than the rest of the world combined. Ariane 6, by contrast, has flown only a handful of times, and even its inaugural mission wasn't flawless. The upper stage failed to complete its final deorbit burn, leaving debris in orbit. But the difference in cadence changes everything. SpaceX can test, fail, fix, and fly again in weeks. Ariane 6 flies rarely, cautiously, and expensively, because it has to, and especially the launch costs simply can't be ignored. At commercial rates, a Falcon 9 launch costs about $67 million. Estimates for Ariane 6 range from 98 to 100 million euros per launch, and that's with hundreds of millions in annual ESA subsidies keeping the program afloat. And then there is the biggest difference of all. When Falcon 9 launches, its first stage comes back. It lands either on a drone ship at sea or on solid ground, then flies again and again and again. The current record-holding Falcon 9 booster has flown 32 times. 32 times! With Ariane 6, every launch is expendable, the traditional way of space rocketry. The core stage falls into the ocean, destroyed after a single flight. That means SpaceX spreads the cost of building a rocket across dozens of missions. Europe has to build a brand new one every time. This isn't a small disadvantage, it's a structural one. The contrast goes a lot deeper than cost. Falcon 9 is human-rated. It has launched astronauts for NASA, private companies, and international partners. More than 68 people so far. Ariane 6 was never designed to carry humans. According to veteran French astronaut Jean-François Clairvoyant, decisions made early in development mean Ariane 6, as built, will never launch a crew. ESA has studied potential modifications, but any crewed capability would be many years away if it happens at all. But Falcon 9 has another ace up its sleeve. The rocket has something called engine-out capability. If one of its 9 first-stage engines fails, the rocket can compensate and still reach orbit. That is not theoretical. It has happened on a real mission before and the payload survived. Ariane 6 relies on single engines for each of the 2 stages. If one fails, the mission fails, simple as that. This reflects 2 very different philosophies. Europe optimized for certainty, SpaceX optimized for resilience. So why is Amazon flying on Ariane 6? Now here's where the story gets interesting. Amazon needs to launch more than 3,200 satellites for its internet constellation, now called Amazon LEO. To meet regulatory deadlines, half of the constellation must be in orbit by mid-2026. Time matters a lot. So why pay more for a rocket that flies less often and has less flight heritage? SpaceX is also Amazon's biggest competitor in the satellite constellation market. Starlink already dominates satellite internet. Using SpaceX to launch satellites meant funding your rival. Amazon signed massive launch contracts with Arianespace, ULA, and Blue Origin, locking in nearly every non-SpaceX heavy lift option available. Only later, after shareholder lawsuits and investor pressure, did Amazon add a small number of Falcon 9 launches to its manifest. Just a few days ago, Amazon added 10 more launches. This wasn't about rockets being equal, it was about avoiding dependence on a competitor, even if that meant paying more and accepting more risk. SpaceX likely never hesitated to accept Amazon as a customer, and it is highly unlikely that they would have treated it any differently than other customers. So the decision might have been made on a more personal level. Another question is, if ESA has no concept for today's reusability-dominated launch market, can Europe's startups change the game? Europe does have launch startups, ambitious, innovative, and determined. Spain's POD Space, Germany's ESA Aerospace, and rocket factory Augsburg. We've covered them all before, but there is a hard truth here. These rockets carry hundreds of kilograms, maybe exceeding a ton to orbit. Falcon 9 carries 20 times that. European startups are targeting the small satellite niche, competing with Rocket Lab's Electron and Firefly's Alpha. That market matters, but it doesn't solve Europe's heavy lift problem. And even Rocket Lab knows this. That's why it is building Neutron, a Falcon-class reusable rocket. The direction is clear. So what does Ariane 6 really represent? Ariane 6 works. It will launch satellites, it will serve European governments, it will guarantee sovereign access to space. And this is something that still matters enormously in a fractured geopolitical world. But measured against the pace and scale of SpaceX, Ariane 6 can never be a commercial breakthrough. It's an industrial policy success. Europe built a rocket designed for a future that arrived early and changed faster than expected. The February 12th launch will demonstrate European engineering skill, but it also feels like a snapshot of a different era. One where access to space was rare, rockets flew cautiously, and paying huge sums for a launch was acceptable. Today's space doesn't wait, and the uncomfortable lesson of Ariane 6 is that even a continent can fall behind, not because it failed, but because it played by yesterday's rules. Welcome back to the Y Countdown, your rapid-fire look behind the curtain at everything that keeps this channel blasting off. Today we'll take a look at the life of a starbase photographer. This is Jordan, one of the most important people on our team. His job is very special but also very demanding. He's the guy who brings you all the images, whether on the ground or in the air. He drove out to Starbase at midnight to film a Booster 19 leaving the production site so that you could see it in this episode. He walks through the dunes regardless of what weather Starbase is facing. He's everywhere all the time. He's all our eyes at Starbase, and for that we are very grateful. Thank you, Jordan, from the entire Y team. If you want to make him smile, say hi in the comments, I'll let him know. Thank you so much for watching. Thanks for being our rocket fuel. We're all in this mission together. And that's it for today. Smash the like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our brand new Raptor emblem design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. And if you want to know how SpaceX managed to build Raptor 3, the new Starship powerhouse, and what makes it special, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode.